Your series is the summation of 1 times 3 times 5 dot 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 2n minus 1 divided by 5 to power n times n factorial. Well, the best way to approach this probably going to be ratio test. So I'm going to try my best to apply the ratio test for this series. We call ratio test. Ratio test says if you take the limit of the absolute value of an plus 1 over an as n goes to infinity, and this guy is equal to L. If L is less than 1, you have an absolutely convergent series, then you can say that, hey, the series is convergent. If L is more than 1, then your conclusion is that the summation of an is divergent. If L is equal to 1, then the test is inconclusive. It means that we have to switch to a different test. So let us begin. We are finding the limit of the absolute value of an plus 1. It means that wherever I see n, I'm going to use n plus 1. So I have 1 times 3 times 5 dot dot dot, and then here I have 2n minus 1 times 2n plus 1 minus 1 divided by 5 to power n plus 1, n plus 1 factorial. On my denominator, I'm going to copy down my an. My an is nothing but 1 times 3 times 5 dot 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 2n minus 1 divided by 5 to power n times n factorial. We're finding this limit as n goes to infinity. Very good. So let us simplify this guy as much as we can. At this point, at this moment, you can basically cancel out 1 times 3 times 5, 2n minus 1, 1 times 3 times 5, 2n minus 1. We can simplify this right away. This guy is equal to the limit of absolute value. Now just multiply these two together, then multiply these two together, and you end up with, so if you distribute 2 into parentheses, you get 2n plus 2 minus 1, or you have 2n plus 1 multiplied by 5 to the n times n factorial divided by, down here you have 5 to power n plus 1 times n plus 1 factorial. N goes to infinity. Very good. So this guy becomes the limit of the absolute value. Up there we have 2n plus 1 times 5 to the n factorial. And down here, you can break these guys down into smaller pieces. What do you have? You have 5 to power n times 5 to power 1, and n plus 1 factorial is n plus 1 times n factorial. Now get rid of the common factors, which is n factorial and n factorial. What else? You have 5 to the n, 5 to the n. So you left what with the limit of 2n plus 1 2n plus 1 divided by 5 times n plus 1. But when you find the limit as n goes to infinity, please note that all of these quantities are positive. So this is just a positive quantity. You don't have to worry about the absolute value. So this guy becomes the limit of 2n plus 1 divided by 5 times n plus 1. As n goes to infinity, this guy is equal to 2 over 5. Okay, we have 2 over 5. What's the meaning of that? Let us take a look at our ratio test. We found this L. This L is less than 1, so we can conclude that the series is absolutely convergent or it is convergent. So this is our conclusion. Since the limit of the absolute value of an plus 1 over an as n goes to infinity is equal to 2 over 5, and this guy is less than 1, by the ratio test, our series is absolutely convergent, and it is a convergent series. Let us summarize what we did. To check the convergence and divergence of the following series, we decided to use the ratio test. The ratio test says, hey, if you find the limit of an plus 1 divided by an as n goes to infinity and it's equal to L, we have 3 scenarios. If L is less than 1, for sure you can say that you have a convergent series. If L is more than 1, it is divergent. And if L is equal to 1, it's inconclusive. So we did the algebra. On our numerator, we have an plus 1. On the denominator, we have an. We simplified this. We got rid of 5 to the n factorial, and we left with the limit of 2n plus 1 divided by 5 times n plus 1, which is indeed equals to 2 over 5 as n goes to infinity. But 2 over 5 is a number less than 1. What's the meaning of that? It means that by the ratio test, we end up with a convergent series.